In this video, I'm going to explain uniform rectilinear motion. But before I start, considering the physical part, I'm going to recall some mathematical skills which are related to the expression of the equation of a straight line in an orthonormal system or in a two-dimensional orthonormal system. So as you can see, it's expressed as y as a function of x, y versus x. This is a straight line. The general rule for a line is y equal ax plus b, where a is the slope and b is the y-intercept. In order to find the slope, we can divide the rise by the run. What do we mean by the rise over the run? This means the run is starting from the initial point of the line. How much did we move horizontally until we reach the maximum point, then the rise from this point to the maximum point on the line, as you can see. So it's equal to the rise or the run over the run, or we can calculate it by choosing any 2 points on the line. The slope is equal to yb minus ya over xb minus xa, where a and b are any points that belong to this line. So in this way we can find the slope a. Now what about y-intercept? How can we find it? Y-intercept, actually, if you substitute for x equal to 0, y is going to be equal to b. So you go check on the graph for x equal to 0. The point on the line that belongs to x equals 0 is this one. So its y is the y-intercept. Then we find, finally, after finding the values of a and b, we substitute them and we say, like, suppose that the slope is 5 and the y-intercept is 6, so it's y equal 5x plus 6. Now moving to the physical part, and what does this have to do with our work? Let's start by the following. We have a puck whose successive positions are recorded, as you can see, G0, G1, G2, and so on. Okay, and you notice that the distance separating two successive positions is equal. So this is d, 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 d. So same distance is being covered during the same interval of time. That's why we know now that this is uniform rectilinear motion. So if we want to calculate the average speed, V average is equal to total distance over time. This could be expressed as by doing cross multiplication, d equal v times t, where v here is average speed. Now, plotting the time equation d as a function of time for these different distances. So we have g0, g1, g0, g2, g0, g3, g0, g4, g0, g5, and so on. If we plot this point, these distances, we're going to obtain the following graph. This graph is an increasing straight line starting from the origin. Why it's starting from the origin? Because at t0, at this initial instant, the puck was started from rest. It was not moving, so it was not covering any distance. Then as time passes till t1, okay, so g0, g1 is going to be the y for the instant t1. Let me use the pointer here to make things clear. So for the origin, no distance is covered because at t0 the object started from rest. Now at t1, this means the object had moved from g0 till g1, so covered a distance of g0, g1. So this is t1, okay, and the point corresponding to it is g0, g1, and so on. T2, we have T2, then this is G0, G2 here. T3 corresponds to G0, G3. It's the distance covered after this time. So it's D versus T is an increasing straight line passing through the origin. And this agrees with the mathematical information that we know, because we know that if a line is in the form of y equal ax, it means that it is passing through the origin, and this is true here. We have d as a function of t is in the form of y, because on the y-axis we have d, and on the x-axis we have t, so it's in the form of y equal ax, where the slope of this line is equal actually to the average speed of the motion. And it could be calculated as rise over run, as we said before, which is again equal to d over delta t, as we discussed. So now how can we use this formula to express x as a function of t, to be able to calculate or to determine the position of the object moving at uniform rectilinear motion after a specified interval of time, or after a specified period of time? So we have that d is equal to v average times t, but we know and we proved that in uniform rectilinear motion v average is equal to v instantaneous. So now I can say that d is equal v instantaneous times t, or times delta t. This means that, what do you mean by distance covered after an interval of time? The distance is actually x final minus x initial. If I want to calculate the distance covered from g0 to g1, it is x1 minus x0. It's the difference between them. So d can be expressed as x final minus x initial equal, instead of v average we wrote v instantaneous times t. Now I want to, knowing the initial position, I want to determine the final position after a certain period of time. So I have to move x initial to the other part of to the other side of the equation, and thus change its sign, because it was minus here, so now it becomes positive, plus xi. So now I have expression of x final as a function of time. X final is equal to v instantaneous times period plus x initial, where v instantaneous here represents the slope of the line, and xi represents the y-intercept, which is b. It's in the form of y equal ax plus b. That's why for the graph of x versus t, if x initial is not on the origin, different from the origin, then it's going to be an increasing straight line not passing through the origin. So again, we can calculate the slope by rise over run. And as we said, this is its formula. We can determine at any instant, for example, at a certain instant t5 here, we can determine the position of the object. So now direct application on the time equation obtained. The time equation of a moving particle p in a space reference OI vector is, so this is the origin and this is the unit vector. I represented the space reference, or the x-axis, with the origin O, and I determined, or I suppose that, in order to be able to explain it to you, I suppose that the magnitude of I vector is equal to 1 meters, because x is expressed in meters. So it's in this direction. Every 1 centimeter on the paper represents 1 meter in reality, which is the magnitude of the unit vector. So this is the origin of the x-axis. Now x equal vt plus x initial, you would either encounter it as xi, x initial, or x naught, which means the initial position of motion. So this formula given here, x equal at plus 4, in which the power of t is 1, is in the form of x equal vt plus x naught. So this means that the motion is uniform rectilinear motion. That's why in the first question we ask, indicate the type of motion. So indicate this is uniform rectilinear motion, because the position time equation, which is x equal vt, which is x equal vt plus x0, so it's in the same form, uniform rectilinear motion. Here no need to justify, because the action verb is indicated. If it was determined, you should say that by comparing x equal at plus 4 to the general equation of the position time equation of the uniform rectilinear motion, and they agree. Now determine the speed of p by comparing the given position time equation x equal at plus 4 to the general time equation x equal vt plus x0. 8, which is 8 the coefficient of t, when we have v the coefficient of t. So v equal 8 meter per second. What is the initial position of the particle p, again by doing comparison? So the y-intercept plus 4 is actually the initial position equals 4 meter. Don't forget to write the units because you are given that x is in meter and time is in seconds. So these are the SI units. Finally, determine the acceleration of the particle P. You already know that because it's uniform rectilinear motion, then the speed is constant. So if we have that the v is constant, then this means that the variation of the v is zero, and by definition, the acceleration is the difference in the speed over the time. So a equals 0 over delta t is equal to 0 meters per second squared. Now summing up the graphs for uniform rectilinear motion, you have that x versus t is an increasing straight line, not passing through the origin if the initial position is different from the origin, is not coincident with the origin of the x-axis. And the equation is in the form of x equal vt plus x0. If you take x0 to the other side, it's going to be x final minus x initial, which means the distance equal vt. And for the graph, v versus t is horizontal straight line showing constant speed, because we said that in uniform rectilinear motion, the instantaneous speed is constant. So v versus t actually gives the instantaneous speeds as long as it's horizontal line. This means that it's constant. And for the acceleration, for uniform rectilinear motion, there is no variation in the speed, so there is no acceleration, and the graph is horizontal line along x-axis showing zero acceleration. You can find here the name of each symbol: x position, v speed, a acceleration, d distance, v node initial speed, x node initial position, and t is the time. So as a summary, in uniform rectilinear motion, the trajectory is a straight line. The abscissa varies linearly with time, which means that in the form of y equal ax b, ax plus b, and the graph is a straight line, inclined line, but no straight line. The velocity vector and the speed is constant. The instantaneous speed is equal to the average speed. The acceleration vector and the acceleration, the magnitude of the acceleration is zero. And the graph of v versus t is a curve, is a horizontal straight line parallel to the time axis showing constant value.